So hi guys, I know that I said I was going to try to find a video on YouTube to help you with solving Half-Life problems. However, didn't find one to my liking, so I've created you this. This is going to break down each time a problem, what to do, and how to go about it. And hopefully this helps. Look at this as you're studying for your exam. Use your homework to help you with this, and so on and so forth. All right, so here we go. We're going to be finding how much remains unchanged. So our example problem is telling us plutonium-210 has a half-life of 138 days and undergoes alpha decay. Determine the total mass of the original 28 milligram sample of plutonium-210 that remains unchanged after 414 days. On the left-hand side, I have my key. I have the only formula that I'm going to be using, which is n equals little t over big T. Then I'm letting you know what our variables stand for. N equals the number of half-lives. That will always be written in black. Little t is the time passed. I will always highlight that in the problem. And then big T represents our half-life, our actual half-life. It will always be written in red. So as I read through this problem, I see this statement that says half-life of 138 days. Because it says half-life of 138 days, I know that this is my big T value. So I'm going to, if I had a pen and writing this, I would label that as big T. Because I'm using the computer, I have highlighted red. Then it also gives me my little t value. I know this because I see a quantity of time following the word after. So I've highlighted that in yellow. Now, I believe I have enough information to solve for n because I have little t and big T. So I'm going to take all my information and plug it directly back into the problem. Over here, I don't know what my n value is, so I said n equals. My little t is 414, and then my big T is 138 days. Got that directly from the problem. Now remember, if they do not give you your big T, if they don't give you your actual half-life, there's table N in the chemistry reference table that will tell you it. They have to give it to you, or you have to be able to find it, or you have to calculate it. So if they don't give it to you, you can find it, or you can calculate it. So as I put in the setup, I go ahead and do that, use my calculator, divide it. I got 414 divided by 138. I get my n value equals 3. That means that my substance has gone through 3 half-lives. It's going to divide itself 3 times in half. So I haven't solved the problem yet. It's asking for determine the total mass of how much is left from the 28 milligram sample that I started with. So I want to know how much is left from the 28. I'm going to go ahead and divide 28 in half 3 times to get my actual answer. So over here, 28 divides in half. 1 time gives me 14, divides in half again, gives me 7, divides in half again, gives me 3.5. So my answer is going to be 3.5. They want to know the mass of how much is left. I go ahead and use my n value to divide the amount I have into the substance. All right. So another example problem of that would be what total mass of 16 gram sample of cobalt-60 will remain unchanged after 15.9 years. All right, once again, I'm using n equals little t over big T. As I read the problem, I can already tell that they're giving me little t. I have a quantity of time after the word after, so I highlight that. For you, you would go ahead and label that little t. Now, as I read the problem, I don't see the half-life, so I either have to think myself, am I calculating half-life or am I looking for it? For this example, you're going to be looking at table N to find it. So table N will tell you that your half-life is 5.271 years. So that's the half-life of cobalt. I go ahead and write that in my red to let you know. Then because I have little t and big T, I'm taking those values and plugging it directly back into the formula. So we have n equals, I don't know what my n is, so I'm leaving n where it is. And we have little t equaling 15.9 divided by big T, which is 5.271. I get approximately 3.01. We round that off to 3. So that means my n value is 3. Now they want to know how much is left out of 16 grams. So I started off with 16 grams. After 15.9 years, how much is left? And I know that 15.9 years is 3 half-lives. So I'm going to go ahead and divide myself in half 3 times. So 16 divided in half would be 8. 8 divided in half is 4. 4 divided in half is 2. Now I'm going to stop right here, thinking that I've done enough. If I haven't done it, I'll continue. If I have, I'll write down my answer. So from 16 to 8, that's 1 half-life. 8 to 4, that's 2 half-lives. And 4 to 2, that's 3 half-lives. So I've satisfied my end value. So that means my answer would be 2 grams. Now let's go ahead. We're going to be dealing with how much was the original mass. Now before we found out how much we had left after the period of time, now we want to know how much we started with. So the problem reads, if 12.5 grams of our original sample of cesium-137 remains after 90.69 years, what was the mass of the original sample? Now, reading this problem, I already know my time passed. Why? Once again, I see that keyword after. So I'm going to highlight that in yellow. Now, as I'm looking at this, I don't see anywhere that can give me my little t, and I see nothing in the problem that says my number of half-life is 4 or 5. So that means I need to either look for my half-life or I need to calculate my half-life. So first, let's look at table N to find out what our half-life is. So when we look at table N, we see that cesium-137 has a half-life of 30.2 years. So that's going to be our big T value. So I have my little t and my big T. I can plug that in and find for N. Once again, I don't know what my N is. My little t is 90.69 and my big T is 30.2. I'm going to plug that into my calculator, divide, and I'm going to get N equals 3. Once again, N equals 3 is not my... So once again, my N value is 3. That is not my answer. So remember, they wanted the original amount. So think to yourself, do they want 12.5 to decrease or do they want 12.5 to increase? Obviously, if you want the starting amount or the original amount, you want it to increase. So that means instead of dividing by 2, we're going to be multiplying by 2. So we're starting from 12.5, and we're going to go ahead and multiply 12.5 by 2 3 times to get our answer. So 12.5 times 2 would give us 25. 25 times 2 would give us 50. 50 times 2 would give us 100. Let's see if we've satisfied our end value. Remember, we had to do this 3 times. So from 12.5 to 25, that's 1. 25 to 50, that's 2. 50 to 100, that's 3. So that means our starting amount is 100 grams. So let's try this problem again. How much was the original? So a sample of SR90 has a mass of 1 gram after 112 years. Calculate the mass of the original sample. Once again, based on the problem, I can already tell you what my time passed is because I see this keyword after and then a certain amount of time. So that is my time passed. Now, reading the problem, I don't see a half-life. I don't see anyone saying the half-life is. So I'm going to go to table N or I'm going to have to calculate it. Let's look at table N before we calculate. So table N will tell us that SR90 has a half-life of 29.1 years. So now that I have my big T and my little t, I'm going to plug it directly back into the formula. So I don't know what my end value is. My little t is 112 divided by 29.1, the information I got from the reference table. That's going to give me N equals 3.84 approximately. Actually. Now, because I need to work with a whole number, I'm going to round that number off to 4. So N equals 4. Now, remember, I want to find out how much I started with originally. Meaning, I don't want 1 gram to decrease. I actually want it to increase. So instead of dividing by 2, I'm going to be multiplying by 2. So let's look like that over here. So because I'm going to be multiplying by 2, 1 times 2 would obviously give us 2. 2 times 4 will give 2 times 2 would give us 4. 4 times 2 would give us 8. 8 times 2 would give us 16. Remember, we have to do this for the n amount of times. N equals 4, so that means we have to do this 4 times. Let's see if we've done it 4 times. Well, 1 to 2 is 1, 2 to 4 is 2, 4 to 8 is 3, and 8 to 16 is 4. So our answer is going to be 16 grams. That's how much we started with. All right. Then we're trying to find out how much time has passed. The question is, what is the total number of years that must pass before only 25 grams of an original 100-gram sample of C14 remains unchanged? Now, I've put over here, we're going to be cross-multiplying, and you're going to see what I mean. When in doubt, cross-multiply. It makes it a little bit easier. So, obviously, we're still working with the same formula. N equals little t over big T. Now, this problem is a little bit different than the other problems because you see now they give you 2 grams, and it's telling you that you started with 100, an original of 100 grams, and you're only left with 25 grams. So we need to find out how much half-life has passed for you to go from 100 to 25. So let's go ahead and figure that out. And as well as finding our half-life of C14, which I found on table N, which is 5,715. I'm going to need this, but for right now, I'm going to find out how much half-life it took for me to go from 100 to 25. So 100 to 50 is 1, 50 to 25 is 2. So it took me 2 half-lives to get from 100 to 25 grams. That means my N value equals 2. Now, because my N value equals 2, and my big T is 5,715 years, I'm going to go ahead and plug it into the formula. Which sadly is over here. So I know my N equals 2. I don't know what my little t is, and I have 5,715 as my big T down below. Now, because I'm going to cross multiply, I'm going to put a 1 underneath my 2, and then I'm going to cross multiply. So 1 times t is going to give me little t, and then 2 times 5,715 is going to give me 11,430 years, and that is my answer. Let's try this again with another problem. So, once again, how much time has passed? A hospital keeps 100 grams of CO60 on hand at all times. Determine the total time that will have elapsed when 12.5 grams of the original cobalt 60 sample at the hospital remains unchanged. Same formula. Now, I'm going to go ahead and find my half-life on table N right away just to help me out. Limit the work. So that's going to give me cobalt 60 has a half-life of 5.271 years. Now, they're giving me 2 grams. They're saying I started out with 100 grams, and I'm left with 12.5. How much half-lives have passed between them? Let's figure that out. So from 100 to 50 is 1, 50 to 25 is 2, and 25 to 12.5 is 3. So it took, sorry, that's a typo. It took 3 half-lives to get from 100 to 12.5 grams. Meaning N equals 3. So I'm going to go ahead and take that information I have and plug it into the formula. Well, N equals 3 equals my little t is what I don't know, what I'm trying to figure out. And my big T is my half-life, which is 5.271. I'm going to go ahead and cross multiply, putting the 1 underneath my 3 so it can cross multiply with the little t. So 1 multiplied with little t will give me t. And 5.271 times 3 will give me 15.813 years. All right, I'll be right back to give you the other set of problems.